Okay, we're going to do number 2 in the practice problems, balancing redox problems revolving potassium permanganate. So here we go. This is without all the positive ions. Let's get started. And let's do the most challenging one first, the in the base solution. Okay, so what you have to do first is find the oxidation number of everything. So let's get started. Let's actually do this in red. Alright, so the oxidation number of oxygen is normally -2 times -4. The charge over here is -8. The total charge has to be -1 because you see that charge there. So what does Mn have to be? It has to be +7. Very nice. Now same thing over here. Oxygen -2 times 3, -6. The total charge has to be -2. So this has to be +4. Right. Same thing over here. Manganese -2 times 4, -8. The total charge has to be -2, so this has to be +6. And then for sulfate, -2 times 4 is -8, and the total charge has to equal to -2, so this is +6. Okay. Then what you got to do is figure out who is being reduced and who is being oxidized. So let's take a look at manganese. Manganese goes from Mn +7 to +6. So that is, if you're adding electrons, you're becoming less negative. So it's basically +7 plus a -1, so that becomes +6. So that's adding electrons. So gain of electrons is reduction. Okay. Just in case, if you forgot. Oxygens are -2, nothing's changing there. Sulfurs go from +4 to +6. So sulfur is, it looks like it's losing electrons, it's becoming less negative. So its loss of electrons is oxidation. Okay, got it? So now let's break this into the half reactions. So I'm going to do the, let's do the oxidation first. It's just my personal preference. SO3 2-. Do not forget the charge. It is easy to do that and easy to mess up because of it. SO4 2-. Notice how I like to circle the charge. Let's switch to black. Alright, remember the order for balancing acid and base redox reactions is everybody orders hot cakes. So you do your elements first, then you do your oxygens, then you do your hydrogens, and then you do your charge. Okay? Alright, so first things first, elements, except for hydrogen and oxygen. Sulfur is balanced. Nice. Now we do oxygens, and you do oxygens via H2O. So we have 3 oxygens here, 4 here, so let's add an H2O here. Okay, that looks good. Oxygen balance. Then you do hydrogens by adding H pluses. Okay, so H pluses, we have 2 hydrogens here, so 2H plus here. That looks pretty good. Sulfur, sulfur. I like to double check every step. Sulfur, sulfur. Oxygen, 3, 4 oxygens, 4 oxygens, hydrogens, 2 hydrogens, 2. Looking good. Now let's do the charge. The total charge here, -2 and 2 of these +1, so this is -2, +2. The total is going to be 0. And on this side, we have -2. So in order to make them the same, we add electrons. So how many electrons do we have to add to this side to equal this? Well, if we add 2 electrons, that'll give us a total charge of -2. So that works. So now this oxidation half reaction is balanced. Now let's do the reduction side. Alright, so let's start out here, and let's put it here. So this is MnO4. Any charge? Yes, negative. Don't forget the charge. And then MnO4 2-. Okay. Elements. Mn first, that's balanced. Very nice. Oxygens. 4 here, 4 here, looking pretty good. Hydrogens, no hydrogens. Now there's charge. The total charge over here is -1. over here it's -2. So in order to get them to balance, we need to add electrons. So we're going to have to add 1 here, and that gives us a total charge of -2. Okay. All right. So looks like this is all balanced here. Now, then what you have to do is combine the half reactions so that the number of electrons cancels. So this gives off 2 electrons, and this takes in 1. Well, in order for this to balance, you have to give off 2 and take in 2. So, how do we do that? Well, let's multiply everything here by 2. Okay? And let's just put everything down here, let the dust clear. So, H2O plus SO3, 2 minus, goes to SO4, 2 minus. And I'm just going to add the other parts underneath it. 2 electrons plus 2 MnO4 minus, don't forget the charge. And then over here, 2 MnO4, 2 minus. Okay? All right. Now that you put them together, let's see if we can cancel anything out. Oh, I forgot the rest of this. 2H plus and 2 electrons. Okay. Well, the electrons cancel. That's the most important part. Hydrogen ions cannot cancel. That can't cancel, none of that business. So let's just put it all together. Our final reaction, H2O plus SO3 2 minus plus 2 MnO4 minus goes to SO4 2 minus plus 2 hydrogen ions plus 2 MnO4 2 minus. And this is where you would put like your states of matter if they gave it to you in the beginning. At the end. So it looks pretty good. Hydrogens, 4 hydrogens. Oh, sorry, 2 hydrogens, 2 hydrogens. 2 MNs, 2 MNs. 1 sulfur, 1 sulfur. 8 oxygens, 8, 9, 10, 11, 12. 4 plus 8 is 12. So everything looks good. And then make sure that the charge is the same on each side. So this is -2 plus 2. Negative 2 times 2 is -4, so that's a total of -6. And then over here, 2 times -1 is -2, and this is -2. Did I forget something here? Oh yeah, -2 and +2, that's 0, so that's -4. So this is -2, -2, -4. Okay, all right, there it is. Balanced reaction. Well, if that was acid, we'd be done. But it isn't. It's in base. So afterwards, in order to balance out the base, we have to add OH ions, hydroxide ions, to every H+. So here we go. How many OH ions do we need to balance out these 2 H+? That's right, 2 OH ions. And just like algebra, you got to add the same thing to both sides, 2 OH ions. Those two come together and make H plus and OH minus makes H2O. And since there's 2 of each, they come together to make 2 H2O ions. So those can cross out. And now let's see if we can cancel anything out here. We'll probably cancel out one hydrogen, one H2O. And then now we're ready to write our final reaction. Like we're running out of space, so I have to be economical. SO3 2 minus plus 2 the manganate anion plus 2 OH ions goes to SO4 2 minus plus one of these H2Os plus 2 MnO4 2 minus. And then you can double check all the ions and all the atoms, make sure they're all balanced. Looks pretty good. All right. Yes. Very good. There you go. It's a hamburger for you.